Friends, this is the third type of integrals involving trigonometric functions. And to solve this, there is a special technique. So let me write down the question for this. So you are given a question of this nature: sin x negative, or I should say positive 3 times cos x, positive 1, divided by sin x negative 3 times cos x, negative 1 times dx. So this is what you are being given, and you got two quantities here, numerator and the denominator. Now take the numerator, sin x positive 3 times cos x positive 1, and this numerator is expressed as a times the denominator, sin x negative 3 times cos x negative 1, positive b times the differential of this denominator, that's going to be cos x. Differential of cos x is negative sin x, so that's going to be positive 3 times sin x, and the differentiation of negative 1 will be 0, positive c. So this is the standard form that you will have to follow whenever you've been given a question of this type. So now what I'm going to do, I'm going to take the coefficients of sin x and cos x and constant term together. So how would I do that? Over here I get a times sin x and 3 times b sin x. So this is going to be a positive 3 times b with sin x. So as I mentioned to you, we are gathering the coefficient of sin x and cos x together. Now in cos x, it's going to be 3 times a with a negative sign and b. So this is going to be negative 3 times a positive b times cos x. That's fine. Now constant term, what is the constant term? A times negative 1, so negative a. There is no constant term for b, so that has to be followed with c. Now on the left hand side we got sin x positive 3 times cos x positive 1. So equating the coefficient of sin x, on the left side you get 1, on the right side you get a positive 3b. That's one equation. Equating the coefficient of cos x, you get 3 here, and on this side you get negative 3a positive b. Equating the constant term, you get 1 is equal to negative a positive c. So we can solve. Let me take this as 2, 3 and 4. So what I'm going to do, I'm going to multiply 2 with 3. So that would give me 3 is equal to 3 times a positive 9b, and I'm going to solve it with equation 3. So there's going to be 3 negative 3a positive b. So you can cancel these two things. So this is going to be 6 and this is going to be 10b. Therefore b is equal to 6 over 10 and 3 over 5. So the value of b is 3 over 5. I got the value for b, and if I were to substitute the value of b in, put b is equal to 3 over 5 in 2, that would give me 1 is equal to a positive 3 of 3 over 5, which is going to be a positive 9 over 5, which is nothing but 1 negative 9 over 5 is equal to a. So therefore a will be negative 4 over 5. So a is 4 over 5. The value of c is what? Put a is equal to negative 4 over 5 in 4. So 1 negative of negative 4 over 5 positive c. This is going to be 4 over 5 positive c. Therefore 1 negative 4 over 5 is equal to c. So c is equal to 1 over 5. So I've got the value of a, b and c. So in place of this quantity numerator, I will have to substitute this. So students, having obtained the value for a, b and c, what we need to do now is to take these values and substitute them in, say, 2. That's exactly what I'm going to do, and that would mean the numerator, which we have just taken here, would now be represented with the terms that you can see on the right hand side. So now the integral is rewritten as integral. In place of a, it's going to be negative 4 over 5 times, I'm actually substituting the values for a, b and c, and the numerator would be represented in this fashion. So that's going to be sine x negative 3 times cos x negative 1, and the value for b is 3 over 5 of cos x positive 3 times sine x positive. The value for c is 1 over 5. So this has to be divided by the denominator, which is sine x negative 3 times cos x negative 1, and this entire quantity has to be multiplied by dx. Now I'm going to use algebraic property. A positive b over c is a over c positive b over c. So with that, I can rewrite these terms as 4 over 5 integral this quantity over the denominator, sine x negative 3 times cos x negative 1 times dx divided by sine x negative 3 times cos x negative 1 positive 3 over 5 times integral cos x positive 3 times sine x times dx divided by sine x negative 3 times cos x negative 1 positive 1 over 5 times integral dx over sine x negative 3 times cos x negative 1. So now clearly we can cancel the terms here, and this is going to be negative 4 over 5 integral of dx positive. Now this quantity, let me just use this space here. If I were to take, let sine x negative 3 times cos x negative 1 is equal to t, differentiating this would give me cos x positive 3 times sine x times the dx is equal to dt. So in place of the numerator I can place dt, in place of the denominator it's going to be t, so this is going to be ln t, and that is nothing but ln of sine x negative 3 times cos x negative 1. So that's exactly what I'm going to be placing there. So with 3 over 5 times ln of sine x negative 3 times cos x negative 1 positive. Now we will have to integrate 1 over 5 times dx over sine x negative 3 times cos x negative 1. Now to integrate this, I have given you a shortcut in the previous question, but anyway, what I will do is I will try to do the integral over here. So let me just consider, I'm going to use this space here, let me just consider integral dx over sine x negative 3 times cos x negative 1. So in place of dx we will substitute the following. So this is going to be 2 times dt. In place of sine x we will substitute 2t. In place of cos x is going to be 1 minus t squared. In place of 1 is going to be 1 positive t squared. So these are the substitutions that will go into the problem. So this is actually the shortcut, but the long way I've already done it in the previous question, so you can just check that out. So this can be rewritten as, in place of dx is going to be 2 times dt. In place of sine x it's going to be 2t. In place of cos x it's 1 negative t squared. In place of 1 it's 1 positive t squared. So this is equal to 2 times integral dt over 2t negative 3 positive 3 times t squared negative 1 negative t squared. So I can add 3t squared with t squared, so that's going to give me 2 times t squared. And is there anything else I can add followed by 2t and negative 3 and negative 1? That would give me a negative 4 there. So if I were to, because this is producing a negative 3, this is giving me a negative 1, so that's fair enough. So this is going to be 2 times of integral. I can take a 2 out. If I were to do that, it's going to be t squared positive t, and in fact I can take a 2 out completely, so it's going to be negative 2 here. So this 2 and 2 gets cancelled. So what I have got here is, let me use the space here, I've got integral dt over t squared positive t negative 2. This is what I've got. Now this can be rewritten as integral dt of t positive 1 over 2 raised to the power of 2 negative 3 over 2 raised to the power of 2. Right? Because I have already shown you how to write it as a square of 2 terms in the previous problem, so you can check that out. Now this is very much similar to integral dx over x squared negative a squared, which has a formula of 1 over 2a log of x negative a over x positive a, positive arbitrary constant c. So if I were to use that, this is going to be 1 over 2 times a is 3 over 2 ln of my x is t positive 1 over 2, right, negative my a is 3 over 2 divided by t positive 1 over 2 positive 3 over 2. So we have to do some simplification. So this is equal to 2 gets cancelled. This will be 1 over 3. Now I can add 1 over 2 with negative 3. So that's going to give me negative 2 over 2. So it's going to be negative 1. So this is going to be ln of t negative 1 divided by t positive 2. So 1 over 2 added with 3 over 2 would give me 4 over 2. That's going to be 2. So this is for my t. But my t is tan of x over 2. Right? This is the standard substitution. So we will have to substitute that quantity here. Okay? You will have to refer the previous question. So now with this substitution, the solution would be completed. So what would be the solution? So let me write the solution over here. Of course, this is what we have got. Clearly we know that this is equal to negative 4 over 5 integral of dx is going to give me x. So it's going to be negative 4 over 5 times x positive 3 over 5 times ln of sin x negative 3 times cos x negative 1, that's fine, plus 1 over 5 times, of course there is a 1 over 3 here, so that multiplied with 1 over 5 would give you 1 over 15. So it's going to be ln of, in place of t, substitute tan x over 2 negative 1 followed by tan x over 2 positive 2. So this is the solution with the arbitrary constant c. Of course it is a little bit compressed because of the lack of space, and I hope you would have got a gist of this question. If you would have followed this question step by step, you wouldn't have any issues at all, because you can always rewind and review this particular question, and it's a beautiful question, students. So we will move on to the next question.